Hey guys, Brett Hudson here from Indie Function. This is another Indie tutorial today, checking out ActionScript 3's variables and data types. Data types are also known as variable types, and let me point out what it is. So, you see at the end of this variable declaration we have the word number, and that's basically a data type. Shape is kind of a data type, but not really, because of this part right here. Data types are predefined, and they're in the language regardless of your imports. We're going to be going over a bunch of them today, and it'll be a lot more clear what exactly a data type is at the end of this tutorial. So the first one that we have is, oh, did I hit caps lock? Oops. Is a number. A number is probably a pretty simple concept to you guys, you know? It's a number. So the way that numbers work is that they can hold any number. This could hold 0, this could hold this number. It could hold a decimal value to quite a few digits. I believe it'll be accurate up to 6 digits, but I'm not 100% sure on Flash's or ActionScript 3's types. Each language is a bit different. This variable, if you want to get technical, is a 64-bit data type, so it holds 64 bits of information. The last 52 being the decimal value, and the first 10 being the actual integer number. And that gets us to our next topic. So private var a random int. We'll call it an integer 5. All right. Oh, one thing before we get into this. If you want to clear the screen from our previous one, clear the screen. Basically what you do is call the clear method on each of these. I don't know why I didn't think of this last time. But when you do this and you run it, you'll see that it goes, and let's also bump up from 0.05 to 0.5 alpha. So once they overlap, you can see the effect there. Alright, however, we don't need to be doing all this anymore, so let's delete it. Alright, we still will use this update timer. We do not need the circle stuff anymore, and we don't need the square stuff anymore. So we will delete that. So let's get rolling. So we have this private variable, a random int. Let's call this something else. Let's call this width or something, okay? And then we'll have a private var height, which is an int, which is equal to, or no, not an int, sorry, a number, which is equal to 4.5. Okay? So the cool thing with trace is you can do width, comma, height. Okay, and then if we run it, conflict, oh, right, we can't use width and height. Let's do underscore width, underscore height, underscore width, underscore height. Okay, so down here we have 5 and 4.5. Now, if we change this to a number, we still get 5. But if we put the .0 at the end, we still get 5. Alright? So, if you're going to be displaying these on the screen, just keep in mind that you will have to do a little extra work to actually get the floating point value, it's called, to be displayed properly. So if you had like a timer that was 5 seconds like this, it would only show 5. And if you had it center aligned, it would get really really weird very fast. So you'd have to do a little extra work. But if we do something like 5.5, we'll see that it comes out as 5.5. What happens if we put it into an integer? Also, I should probably mention, in case you guys need a refresher on what an integer is, or have never encountered them in math, an integer is a whole number. 0, 1, 2, 3, 4, -1, -2, -3. It cannot have a fraction or a decimal point after it. So we're putting a decimal point on here, okay? What's going to happen? It literally just chops it off. It doesn't exist anymore. It just says, oh, hey, you have a period here, let's delete everything after it. So you're probably wondering, so if we do a negative 5.5, it's going to be -5 or -6? It'll be -5. It literally reads up to the decimal, chops everything off. So there's some simple stuff. So what happens if you multiply an integer by a number? Let's find out. So -5 times 4.5. Alright, so if you have one number in here, you will get a number result. And you're probably wondering, like, why does all this matter? Once you get into this and you start messing with the different data types, using them in different combinations will create different effects. So let's cut this down here and put it in here. Also, why did we use this? Why didn't we do width times height? Alright, so every single time. So what we're going to do is we're going to do width plus equals 0.5, height plus equals 0.5. We're going to change this exclamation mark, or, wow, this multiplication sign to a comma. So we're going to get two numbers, and you can see the second number is going up, and the first number is 0. Go all the way back to the beginning. Starts at -4, goes to 3, goes to 2, goes to 1, goes to 0. That's actually really weird. Let's try it with +5. Alright, I had done it with +5 earlier and it didn't do that. So, I think what... Oh, I know what's going on here. Okay, so if we have -5, alright, and we add this, we get -4.5. It truncates the end. Alright, so now we have -4. The next time around, it goes to -3.5. Truncates the end, we have -3. Next time around, it goes to -2.5. Truncates the end. 1.5 truncates the end. 0.5 truncates the end. So now we have 0. Next time it's 0.5. It truncates the end. It's still 0. That's something that I've never thought about before, was what happens if you are adding 0.5. Because usually if I'm dealing with negatives, I'm increasing it into the negative span, aka subtracting 0.5 instead of adding it. Which you could also do this way. Or literally just doing that since it's a bit simpler. Alright, learn new things every day, right? So let's play around with some more stuff. So let's just run this one more time. Second number goes up because it can hold the 0.5. First number does not. Alright, now there's another thing that can happen, which we're going to comment this out because we don't want to see that. So we're going to do width divided equals to height divided equals, oops, 2. Okay, this right here is the same as doing width equals width divided by 2. Same exact thing. You could also do the same with the multiplication operator. So let's trace out width, comma, height. You could also do width, comma, height, comma, Oh, we put a colon on there. So it shows width and then height. So, what happens when you take 5 divided by 2 is you get 2.5, truncates the end, it just puts it to 2. Since we have a number here, it's 4.5 divided by 2, which ends up being 2.25. And since it's a number, it does not truncate the rest. So I think you guys have a pretty solid understanding on that. There is another type of int called a uint. It's an unsigned integer. So what unsigned means is that it cannot be negative. If you try putting it as a negative number, it's not going to be happy. So let's do that. Let's put it to -5. Delete the division stuff. See what happens. All right, so you put it as -5, and in Flash's case, it literally just makes it a positive number. Other programming languages will not be so happy. Some of them will spew out errors saying, hey, you can't have a negative unsigned int. Others will put it up to the maximum number, which is a bit over 4 billion. Integers can only go from -2,147,000 blah 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 up to positive 2,147,000,000. So if you are having numbers that are bigger than this, I don't know why you're using Flash, because whatever you're doing is going to be very, very technical, and Flash is great for making games, but using that big of a number, you're doing some CIA undercover stuff. Alright, I have no idea what you're trying to develop, but it is way beyond these tutorials. Alright. So, uint basically takes it, instead of being -2.147 billion to positive 2.147 billion, it says, once you add the u, it says, oh hey, let's take all these numbers and add it to this. So then you have 4.294 billion, alright? Still, if you're using that much, or that big of a number, my mind's going to explode, because I have no idea what you would need that big of a number for. Maybe time, but still. Also, the bigger the number, it doesn't take up more memory in your system. Every number takes up the same amount of memory. Integers and unsigned ints take up 32 bits, which is the equivalent to 4 bytes. 8 bits is a byte. So this right here is 4 bytes. This is 8 bytes. Your RAM probably has a certain amount of megabytes or gigabytes. So using these variables isn't going to take up a whole lot of space on your system. And they're deleted when the program's over. So, no biggie. Alright, so the next type that we want to check out is called a string. Private var with string, we're going to call it. And it's going to be a string. Oops, whoa, what just happened? Alright, so what a string is it's a string of letters, numbers, symbols, and whatnot put inside quotation marks. Alright? So now here, we can put in with string, and you'll see that it outputs that. Let's do the same thing for height. So I'm going to cut it. Private var height string is equal to that. You might also want to call it height text. You know, that would be an alternative. But we're just going to call it height string. I mean, you could call it whatever you want. You could call it boo, and it'd still work. But let's see here. So we have strings. Let's play around a little bit. Let's take this out. So now it doesn't have a colon. What happens if you do with string plus equals colon? You'll see that it appends it. All right. So strings can actually take in extra stuff at the end. So let's get a bit interesting. We're going to delete width from there, and we're going to do plus width. What's going to happen? In this case, it just adds it onto the string. In certain cases, if you ever have problems with this, it's probably because you're taking a number and adding it with a string. Like if we were to possibly do the width before and add the string after the width, you might get some weird results. That's just because you're using different variable types. How do you take numbers and letters and put them together? That's absolutely unheard of. Algebra. Yeah, so there's even more variable types. Another one that I think we actually already used was a Boolean. These are either true or false. So private var off equals false. I don't know why I put that to false. So we have two Booleans, and on is true, off is false. Let's just keep putting these underscores there just because we have previously. You can also trace these out. So let's do on, off, true, false. Yeah. You can literally just put in things like if, you know, on. If on is true, same as if on is equal to true. Trace, hello. If off, trace, hello again. Okay, so we'll get hello because it's set to true. We won't get off. You can also do different things with these. Now, you're probably thinking, can we add them? Let's find out. Alright, so if we add them, I don't know what happened. If we multiply them, it's mad. Actually, I do know what happened when we added them. Alright, so basically on is equal to true, which is equal to 1. Off is equal to false, which is equal to 0. So what it does is when you have on plus off, it's equal to 1 plus 0, which is equal to 1, which is equal to true. Alright, any number is equal to true, except 0. 0 is false. Any other number is equal to true. Any other number. So if you guys want to get creative with your numbers, you can actually like put 0 here and then check to see if width. And that could be kind of clever, because if width is 0, it's been unset. Or unset, well, it hasn't been set yet. If it's a number, then it has a width. Alright, makes some logical sense. There's lots of different ways that you can use that. Alright, but there's another way that you can check to see if it's been set or not. It's called null. Null right here is basically saying that it has not been set. It's 100% not set. So let's see what happens here. Incompatible default value of null. Alright, we can't put null here. Shoot, I should have known that. So let's create a private var circle shape, which is equal to null. Okay, so now if we try drawing the circle, circle, oh, it's being smart. Graphics.draw circle. So let's try drawing it at 50, 50, 55. We also need to do circle.graphics.begin fill 0x and circle.graphics.end fill. It's probably not going to compile. Oh, we're we're using a circle. That's why. Okay. That's why it didn't. Okay. Graphics. Should probably spell graphics correctly. Okay. So it crashes. This is probably the first time we've seen it crash. Cannot access a property or method of a null object reference. Null means that there's nothing there. Alright? So if we're trying to say, hey, this circle that definitely exists, I want to access the graphics of it. Alright? If it doesn't exist, how do you take something of 0? It's like multiplying a number by 0. You're just going to get nothing in return. So if we try doing this, we're getting nothing of nothing, and the computer's like, what's going on? That is not cool. I'm going to crash on you. So, why would we want to do this? Alright? It's going to make more sense once we get into games programming. But one thing that you can do is you can check to see if circle. And what that is doing is it's checking to see if it's not equal to null. Null is also kind of 0, except it's a bit different. So if circle, then draw it. It will not crash, but it will only do this if the circle is not null. So let's make circle equal a new shape. So now it's not null. It has a value. And it's still not drawing. It's inside update, right? Oh, right, duh. No, okay. I'm dumb. I'm not sure what's going on here. Oh, right. I do. Add child circle. I'm so used to working with Flashpunk that just working with barrel flash is confusing. Okay, so there we go. We have that. Yeah, I'm really excited to teach you guys Flashpunk because I'm sick of doing all this. Okay, so those are all our variable types, or data types, I should say. One last type is called void. Alright, you've seen it here. Void means that it doesn't have a type. Alright, and you're like, whoa, this public function is a variable? No, it's a function. However, it's got a return type that's void. Alright, this one has a return type that's void. Basically what this means is that when you call these functions, you're not going to get back anything from them. Alright, we haven't really worked with stuff that returns. This kind of returns, like this isn't a function, this is the constructor for the shape. But basically, you could call a function, and it would return a variable, and you could put it, or it would return data, it would return something, and it would store it inside a variable. We'll get into that, and let's see here. It looks like it is tutorial 8 or 7. Can't even read my own Roman numerals at that. Alright, so still 3 more tutorials away. So this has been a pretty good look at the basics of how variable types work. Pretty much covered it all. There is one other type called object that we're not going to look at because we just don't need to look at it. You know, it's not that important. So catch you guys later with the next tutorial, Mathematics in ActionScript 3, where we take a look at a little bit more of adding and subtracting and doing whatever with integers and numbers, as well as checking out a cool library within Flash, or a cool class, I mean, not library, a cool class called Math. So, we'll catch you guys later.